All right, here we are in Learning Target 6 and 7. And previously in Learning Target 5, we were introduced to imaginary solutions to quadratics and how to represent an imaginary solution when that negative number appears underneath your square root. For example, the square root of negative 1 just becomes I, and the square root of negative 4 ends up being the square root of 4 is 2, and the square root of a negative number is I, so we would say 2I. So if we look at this base model here, I equals square root of negative 1, and we perform an operation to both sides, that being a squared, we would get I squared equals, squaring a square root cancels that operation out because they're inverses. This I squared equals negative 1. Now this is going to be very important when we get to multiplication of what's called a complex number, and you'll see that in a second. But let's first talk about what a complex number is. In general, we represent it as A plus BI, where A is called your real part and B is called your imaginary part. So for example, 3 minus 4i, we know that 3 is your real part and negative 4 would be your imaginary part. Or if you just wrote the number 2i, there's not just an imaginary number there, there's actually a real part of it too, but it just happens to be 0, so we wouldn't write it. So every number can technically be written as an imaginary or a complex number. If I write the number 2, well, yes, that is a real number, but I can represent it in the complex world and say 0i. I could write it like that. All right, so now let's move on to some operations here. And this should be familiar to you because we've done this in Algebra 1, you just never were introduced to I. So let's look at an example, 2 plus 3i plus 4 minus 2i. So in Algebra 1 you always combine like terms, and this is the exact same thing when it comes to complex numbers. You look at like terms. For example, 2 and 4, they're like terms. So when I combine 2 and 4, I would get 6. And I, they are now like terms, just like x's are like terms. So 3i and negative 2i, they're like terms. Altogether, how many i's do I have? You have just one I. So that would be the sum of two complex numbers. Now when it gets to multiplication, we want to remember that I squared is equal to negative 1. I'll show you where this comes up. If we multiply out 2 plus 3i times 4 plus I, we get, now I'm going to use my box method because this is what we've been using in the past. We'll have 2 and 3i and then 4 and I. So in this box I would have 4 times 2, which is 8, 4 times 3, which is 12, but I have an I there, so it's 12i. 2 times I is just 2i. 3i times I is now 3i times I, which is 3i squared. Now, like we've done in this area model before, now to find the total area of a rectangle, we just add the areas of the 4 rectangles. So here we would have 8, 12i plus 2i, I would get a total of 14 i's, and then 3i squared. Now this is where we want to remember, once again, that I squared is equal to negative 1. So we have 3 times I squared, which is really 3 times a negative 1. So what we really got here is 8 plus 14i plus a negative 3, because 3 times negative 1 is negative 3. So we're going to combine like terms here, just like we did with the addition and subtraction on the left. So 8 take away 3, I would get 5 plus 14i. So there's the product of two complex numbers. There's no I squared, becomes negative 1, and then we just combine like terms to find our resultant.